Let's dive right into how to solve this problem. This asks us to solve this inequality with two absolute values in it. So how in the world would we approach that? It's not like there's only just one absolute value. We know how to do that very well. You should have learned this in like algebra 2 or pre-calculus, something like that. Even algebra 1 maybe. You would have two branches. You have x minus 1 greater than 5, and x minus 1, you would have the opposite. So less than negative 5, and then you would solve from there. Okay, but that's not what's happening here. There's two absolute values. So how would we solve this without a calculator, without looking at without a graph from a graphing calculator, something like that? Okay, so maybe let's try to graph this by hand so we can see if when it's greater than 5, if it is at all. Actually, the answer is no solution, so I'll give you that already, so we'll see why. Okay? How would we graph this? We could, of course, just start plugging in values of x, get a table of values, but that's slow and not very precise, because what if we miss some critical points? So what's a better way to do it? Well, remember, we can write an absolute value as a piecewise function. You can say absolute value of x is equivalent to minus x for x is less than 0, and x for x is greater than 0. And it doesn't matter where you put the equal sign because it's continuous, so it doesn't matter where you put it. Okay? So we can break up absolute value as a piecewise function. The important point is when inside the absolute value is 0, that's like the switching point, right? Less than 0, that's the switching point. It's on the negative branch. Greater than 0 is on the positive branch. So we're going to rewrite this as a piecewise function. So first, let's move everything to one side. Oops, 3 minus x minus 1 minus 5 greater than 0. Usually, it's easier to solve inequalities like this anyway, right? Because it's easier to see if it's positive or negative. Greater than 0 or less than 0. Okay, so as I said, the important point is the switching point when inside the absolute value is 0. So when is the inside the absolute value 0 for this? That's when x is 3. And similarly for this is when x is 1. So we're going to break up our limits of x like that. So let's say our f of x, I'll write it one more time, is x minus 3 in absolute value minus absolute value x minus 1 minus 5. Okay? So let's rewrite this as a piecewise function in 3 branches. When 1 comes first, right? X is less than 1. That's one branch. 1 less than or equal to x, less than or equal to 3, and when x is greater than 3. As I said, 1 is a switching point, so everything before 1 up to 1 is one branch. 3 is another switching point, so between 1 and 3, and then everything after 3. Again, 3 is the switching point. Okay, so when x is less than 1, is this on the positive or the negative branch? That's on the negative branch, so it will be minus parentheses x minus 3. This is as well on the negative branch, so be careful with your notation here. Minus x minus 1, minus 5, like that. This minus comes from that. This minus comes from more on the negative branch. Okay? Between 1 and 3, well, now this is on the positive branch, but this is still on the negative branch. So we have minus parentheses x minus 3 minus, this is positive, as we just said. Okay? And when x is greater than 3, both of them are on the positive branch, so it'll just be x minus 3 minus x minus 1 in parentheses, minus 5, like that. Now let's simplify. Be careful with the signs. This is minus x plus 3. Two negatives make a positive, so it would just be plus x minus 1 minus 5. This is x is less than 1 branch. Over here would be still minus x plus 3, but the next terms would be minus x plus 1 minus 5. This is 1 less than or equal to x, less than or equal to 3. And over here would be x minus 3 minus x plus 1 minus 5 for x is greater than 3. And let's simplify. Minus x plus x, that's 0. 3 minus 1 is 2. Minus 5 is minus 3. So x is less than 1. That's that branch. Minus x minus another x, minus 2x. 3 plus 1, 4. Minus 5, minus 1. So 1 less than or equal to x, less than or equal to 3. X minus x is 0, minus 3 plus 1 is minus 2, minus 5, that's negative 7, right? So x is greater than 3. So this is how, whoops, I got cut up, but I was saying what I was writing. This is how the function looks. as we wrote it as a piecewise function. So let's see on the calculator if this is correct. So this is how it looks. -3 flat is a constant for x is less than 1. Where's my x-axis? 1 is here, right? Okay. Let me try to zoom out a bit. There we go. So it can fit it on screen. -2x minus 1 for x is between 1 and 3. That looks right. This is a slope of -2, right? If we go down to right 1, yes, that's correct. And this is flat -7 for x is greater than 3 right there. So this is how our function looks. Okay? Now, let's answer the question. We just move this 5 to this side. Is this ever greater than 0? Is it ever positive? It's not. We even just saw the graph, right? 0 is up here, but the graph is down here. So there's actually, as I said in the beginning, no solution. And we were able to tell from this piecewise function, which we can graph by hand, also sketch by hand also from here. All right, so hopefully this was helpful. The key point was, at least how I would solve it, is break this absolute value up as a piecewise function. It's a good strategy to use here if you're not allowed a calculator. Okay, so hopefully this was helpful. Hopefully this is interesting if you were just curious. Please like and subscribe as always if you liked this video. And hopefully I'll see you in the next video. Bye.